Aabel sir,
have
one request.
okay.
We are recording this class, but the problem is you have to write the letters in a bigger size.
Okay, okay, right. So that
Because some part of the screen is visible. Some part means 3/4 of the screen is for your writing space, and 1/4 is the student's uh, name and other things in there.
okay, okay. So let me draw this thing. So up to here, I would like.
Yeah, you can use your full screen, not an
Okay,
issue.
okay, right.
After the if somebody want to watch the recorded class, then that time the letters will appear as a small one after the recording.
Okay,
Live
that
class
I'll
will
do.
not be an issue. Okay.
Yeah, done. Right. Okay, so uh, to start with the problem, we have a problem, two problems left off in the previous class. Okay, right. So, uh, so let's start with the problem. So the problem is find the value of the relation. Find the value of the relation. Uh, yeah, relation is P is equal to I cross A cross I. Okay. So before that, yes. So yeah, one more small thing that we forgot to mention is the vector triple product. Okay. So yeah, let me write the problem once, and we'll discuss the vector triple product. Then we'll do this problem. Right. Uh, Plus J cross A cross J plus K cross sorry, uh, K cross A cross K. So this is the relation. So you need to find the value of this relation, right? So we have discussed about the vector triple product. Hello.
Hello.
So
Sir,
yes.
sir, അയിന്റെ ഇടയില് ക്രോസ് ഇല്ല.
Yes, yes. Sorry. Okay. Thank you.
ഫസ്റ്റ് ഇല്ലേ?
Yeah. Right. Okay. So vector triple product. Vector triple product. So uh, we have discussed the product of two vectors, and now we are discussing the product of three vectors. Okay, so product of two vectors, we have discussed dot product as well as cross product. Now if you're discussing about the product of three vectors, there is a scalar triple product, which gives the volume of the parallelopiped with the sides as the uh, vectors. Now next one is the vector triple product. Okay, so that is A cross B cross C, right? So how will you do this A cross B cross C? So A cross B cross C is the relation is like this. We have, if we have three vectors and if you are writing in the form A cross B cross C, so this is the form of vector triple product. Just like that, A dot B cross C, if you are doing both cross product. Okay, A cross B cross C. So we'll get a vector. Obviously, we'll get a vector because B cross C will get a vector, and A cross B, A cross that entire thing is another vector. But in A dot B cross C, we'll get a scalar because this B cross C is a vector, and A, if it is dot producting with another vector, will get a scalar. So vector triple product, the product will be a vector, and scalar triple product, the product will be a scalar quantity. So this is how you will do. It is B into, is B multiplied by B into, there is no dot, B into A dot C, A dot C. Okay, so minus C into A dot B. So this is the general relation of A cross B cross C. This is a vector triple product general relation. So you remember this back minus cab rule. So this is back minus cab rule. Just remember like this, back minus cab rule. Sorry, cab rule. So this CAB and BAC, you just remember. Okay. So if it is in the form of A cross B cross C. So if it is in the different format, just like B cross C cross D, we'll do accordingly. Okay. So this is for A cross B cross C. Please remember that. Right. Okay. Now to represent this thing, how will you represent this thing? So actually, this is actually if you have this one, if you have three-dimensional space over here, and if you have three vectors, will span the space. This is A vector, this is B vector. Suppose this is B vector and this is C vector, and we have this A cross B cross C as a vector, which is this. Is this actually it is in the B cross C? Actually, it is the BC plane. This plane. So this is actually A cross B cross C. It is actually a vector in B and C plane. So just the idea, get the idea of this A cross B cross C. This is actually a vector in B and C plane. So this plane, the vector lies, and which will be perpendicular to A. This will be perpendicular. This is the perpendicular direction. Okay, this is the 90-degree. So this will be perpendicular to A vector, and which lies in the BC plane. So it is A cross B cross C is a vector which lies in B and C plane. Okay, and which is perpendicular to vector A. So this is the idea of A cross B cross C. Okay, and if it is something else like B cross C cross D or C cross D cross something else like that, we'll do accordingly. So please remember that this will be the plane. So this will be the plane. Okay, this is the plane, and this vector will be perpendicular to this planar vector. Okay, so both will be perpendicular, mutually perpendicular to each other, obviously, and this A cross B cross C is perpendicular to A vector. So if you are asked this question, what is the direction, or what is the what is the idea of A cross B cross C? So A cross B cross C is a vector which lies in the BC plane and which is perpendicular to A vector. So this is the general idea of A cross B cross C vector. Now there are some property of that also. So we have discussed the properties of scalar triple product. Now we will discuss the properties of vector triple product. Okay, right. So if you are doing is it in the cyclic manner. So just if you want to memorize, so if you have the second property, so secondly, if you have given like this, let's say it is B cross C cross A. It's just a cyclic change, okay, which is equal to, what do you mean to say? So just memorize this thing, A, B, C. just memorize this as ABC. Then it will be equal. It will be easy. Okay. Then back minus cab rule you can apply. It will be what? It will be C into, yeah, C into B dot A minus, what will be this? A, second one, A into B dot C. So I am memorizing this back minus cab rule here also, applying this also. So if you have the next one, it will be C cross A cross B. Sorry, C cross, yeah, C cross. If it is, yeah, if it is difference, okay. So if it is the same manner, you can apply this back minus cab rule. If it is in the separately, C cross B cross A, instead of A cross B, it is the changed one. Okay, so if you are applying back minus cab rule, it will be like this. It will be how it will be. It will be, see, just look for this, minus B into C dot A plus A into B dot C. Okay, so it will be like this, right? So please memorize these operations, because if you are given some other form of this vector and if it is cross product, you need to apply this back minus cab rule, but you will have a confusion if it is not ABC in the form of ABC. So you'll get confused. So just memorize this back minus cab rule. Okay, right. Now, so one of the other properties, if you add this thing, okay, so if you add this thing, we have another property. It's a property of vector triple product A cross B cross C plus, in the form of cyclic manner, B cross C cross A. Okay, next, plus C cross A cross B, which will be equal to 0. So this is another property of the vector triple product, right? So this is a property of vector triple product. Now, if you come back to this problem which we have discussed, so how will you do this problem? So the problem is, so let me write that problem once again. Yes, I is the unit vector, I cross A cross I. So can you do it? Just please try to do it. Plus what will be the answer? Just try to do it. J cross. So as I have given in the sheet, yeah.
Sir, A dot I A എന്നല്ലേ?
A dot I. A dot I or A cross I? What are you thinking?
A dot I.
A dot I means if it is A vector, how many directions does A vector have? Whether it is AXI, AYJ, AZK, it is not A. Because A dot I means the projection in the I direction. Okay. So A dot I means whenever A dot I is equal to A, then A vector will be AI only. Okay, if you have three vectors, then A dot I will be A. Because A dot I is the projection of A vector along I direction. That is actually the component of A vector along I direction. It will give, whether it is A or whether it is AX or whatever it is. Okay, it will give. Because if you have A vector as AXI, plus ayj plus azk. If you have a three-dimensional vector, then a dot I will be equal to ax. It is true, right? Okay.
Sir,
Yes.
this I dot I equals -1, right?
I dot I.
Mm.
I dot I is not -1, it is 1.
Oh.
I dot I. I dot I means that angle between I and I, right? That is 0. So please check the angle between I and I. That is 0. Then I dot I will be I into cos 0. Okay, cos 0 is 1. I, the unit vector I. Unit vector I, the modulus will be 1. So the I dot I will be 1. Okay, so now we are discussing cross product here. If it is A cross I, what will be this? And it is vector triple product. Just make this in the form of vector triple product. That is A cross B cross C. So if you change it to A cross B cross C, it will be easier. So what is the answer? Plus K cross A cross K. Right. What will be the answer?
Sir, is the answer 0 or 2A?
0,
2A.
not 0, it is 2A. We have the options. I think
Okay, sir.
you have given 0A, 2A, and none. Okay. So the answer is 2A. Please check your answer. If you are getting that answer, please check it. So everybody getting? Because this I cross A cross I, let me write this I cross A cross I. It will be,
Sir,
yeah,
A dot 1 is equal to A, right?
A dot 1 is A. Okay. Yes.
Okay. Then first one, that is I cross A cross I is equal to A minus AX, right?
AY, A minus,
A minus,
I think, uh, so I think, let me do this thing. Okay. What is A cross I? So let me take it like this. Let's say A equal to, since it is a three-dimensional form, okay, there are I, J, K. First you need to do is, you need to define A. Okay. So this is the first step. So let's say A is equal to a component of AX into I cap plus AY into J cap plus AZ into K cap. Just say like this. This is a common vector in three dimension. Okay. So you can write whatever it is. It is you can write it, if instead of AX you can write A1, AY you can write A2, AZ you can write A3. Just as your wish. But what I've written is, if it is AX, then it is clear that it is the component of A along X direction. AY, it is a component along A vector in the Y direction. Just to understand that, I have written AXI, AYJ, AZK. Okay, so this is the three-dimensional form of A vector. Okay, just define that first, then we will do the next. So what is A cross I from here? What is A cross I? A cross I. Next step is A cross I. So A cross I is just equal to AX I cap plus AY J cap plus AZ K cap cross I, right? Okay. What is I cross I? First one. So because this is a common rule of multiplication that you are using, distributive law. Okay. First you need to multiply AX with I, AY with this term with I, and this term with I. That's it. Okay. So what is the answer here? It will be, what is AX I cross I? AX is the scalar one. Okay. AX is the coefficient. Okay. AX into, we are multiplying I cross I, right? What is I cross I? What is the angle between I and I? It is 0. Okay. Then I cross I will be
1.
what? No, not 1. This I dot I is 1. because I cross I is what? I into modulus of I into modulus of I into sine of the angle
Sir,
between I and
sir,
I. Yes.
sir. This I cross A dot I could be written as A dot I minus I dot A dot I.
I
Right.
cross this one.
This one could be written in the other form, right? That is vector triple product.
Yeah, you can write it like that, but I think it won't come like that. So let me do the other way also. Just I'm simplifying this. I'll do this in the both way. Okay, no problem.
Okay, sir. Okay, sir.
Right. So here, what happens? First one. This is actually simple understanding. I am doing this. Ax into I cross I. I cross I is 0. Okay. Then I j k in the cyclic form. Okay. This is the cyclic form. So what is j cross I? What is j cross I? J cross I. Okay, j cross I will be minus k. Okay, so we are returning in the writing in the backward form. Okay, if I cross j is there, then it is this plus k. Okay, if it is j cross I, then it is minus k. Okay, so now first one it will be 0 ax. So ax component won't be there. So just memorize or just understand this. If you are writing like this, a cross I, there will not be an I component here. Okay, so I cross I will be obviously 0. So if it is a cross I, there will not be an I component. Only j and k component will be there, because I cross. So we are actually doing j cross I. Okay, j cross I is what? J cross I is minus k. So ay into, so the component will be ay into j cross I. J cross I is what? Minus k plus az into what? Sorry, az into k cross I. K cross I is what? K cross I is j. Right. K cross I is j. So this is the component. This is the component that we got. Okay. So what is here? So it will be what? Minus, yeah, it will be minus ay, sorry, az into j. Okay, az, 1 second, az into j minus ay into k. Right, az into j minus ay into k. Right, ay into k. Right. So this is the answer that we got for I cross a cross I. Right. Now next one. What is j cross? Can anybody say a cross j? It is, yeah. Okay. Now we have written a cross I only, right? 1 second. We have written a cross I only, right? Now we need to do I cross a cross I, right? We didn't do it, right? Yeah, we have written only this one, a cross I. Okay, now we need to do I cross a cross I. So what is I cross a cross I here? Just take a cross product. It will be I cross j. I cross j will be what? I j. It will be k. So it will be az into k minus I cross k is what? I cross k is what? If you are writing vector notation, the vector calculus, if you are doing any calculations on the vector, just memorize or just write it somewhere like this. Okay, this will be very important. Okay, I j k. If it is I cross j, this k. J cross k, it is I. K cross I, it is j. So just do the cyclic thing. Okay, just memorize this cyclic thing. and if it is in the opposite direction, it will there will be minus. So here what happened? Next, ay into ay is a coefficient. Ay into what is I cross k? I cross k is this one, opposite. Then it will be minus j. So this minus and minus will be cancelled. Then it will be the answer, right? So this is I cross a cross I, azk plus ayj. Now, what is j cross a cross j? So I am doing right away. What is a cross j? A cross j means we have ax I cap plus ay j cap plus az k cap cross j, right? Okay. So then what happened? J cross. So this quantity will not be there because j cross j is 0. What is I cross j? It is k. It is ax into k cap plus what is k cross j? K cross j is minus I. Okay, there will be minus. So there will be a minus. I hope you are getting this. Okay, minus what is k cross j? It is minus I. So it will be az into I cap. Now, if you are multiplying this, it will be j cross k. J cross k is what? I. So it will be ax into I cap minus j cross I. What is j cross I? J cross I is minus k. So there is a minus and minus. So it will be plus az into k cap. So this is the answer to j cross a cross j. Please note this. It is a very important thing. So we are doing this calculations in the j format. Okay. So j cross a cross j. So there will not be a j here. There is only I and k. Okay. So that is a property, or that is an importance of doing cyclic calculations. Okay. So if you are doing it with a j, there won't be a j component over here. Okay, right. So similarly, we have just do this thing. So just try to do this thing. What is k cross a cross k? What will be the answer? Please try to do this thing. K cross a cross k. What is the answer? K cross a cross k.
Ax I plus
Yeah.
ay.
Yes. So simply, if you can understand the format, it will be very easy for you. Okay. See, I am putting I here, right? I cross a cross I. There won't be an I component here. So only this thing. And please remember that if you have this k component here, here it will be az, because k is the unit vector along z direction. So there will be only az. So a component will be az. So j's component will be what? It will be ay, because in the y direction. So here also this is I component. It is along the x direction. So ax. It is along the z direction. It is az. So from here we can directly write. It will be simply axi plus ayj. That's it. Okay. So if you are adding this thing, what happens? It will be axi plus ayj plus axi plus azk plus azk plus ayj. So there are always two of them. So what is the entire relation? It will be equal to So let me write it once again. Azk plus ayj plus axi plus azk plus axi plus ayj. So there is this I component. This is ax. Here it is ax. So 2ax. So we have 2ax into I cap plus this is ay and one more ay is there. So it is 2ay j cap plus similarly 2az k cap. So 2 we can take it outside. It will be 2 into axi plus ayj plus azk, right? And that will be equal to what? 2 into a vector, right? So this is how you do it. Okay. So I have written this thing because for you to understand how you'll do cyclic calculations. Okay. So if you have whenever if you have a cross product, just remember that if you are doing cross product, what happens? If you are doing cross product of some whatever the coefficient is, whether it is x, y, z, whatever the coefficient is. So if you are doing I cross j, we always give the other what? The other coordinate. Okay, since this I cross j is nothing but if you have two directions. Okay, so if it is I cap, if it is j cap, this I cross k will be in the form of, what is the physical meaning is that I cross j is the rotation from I to j, rotation of the vector from I to j. So if you are rotating a screw, as I said in the earlier class, if you are rotating a screw from I direction to j direction, which direction the screw will go? If it is a right hand screw, which direction the screw will go? It will be going upwards. Okay, from I to j. Just if you put your hand here on top of I and j, on top of this plane, and rotate the screw will come upside. Okay, so that is the direction of the other vector, and that will be k cap, always k cap. Okay, since I and j are mutually perpendicular to each other, k will be also perpendicular to I and j. So these three vectors will be mutually perpendicular for in the case of I, j, and k. Okay, so please, I hope you have understood this thing idea. Okay, now we'll do the other thing. I think there is no need to do the other thing because we have. I'll do one calculation. Okay, so I cross a cross I, right? What is I cross a cross I? So it is, if it is a b c, if you're putting back minus cab rule, it will be a into, yeah, I dot I. So as you said earlier, a into I dot I minus cab rule, cab, the I into, yeah, I into a dot I, right?
I dot I.
I dot I. No, back minus cab in, so I dot A, right?
The same.
Okay, A dot I and I dot I are same. Okay, no problem. I'm just going into following the format. Okay, I dot A, right? So this is I cross A cross I, right? Right. So it will be A vector I dot I minus, what is this? I dot A. So yeah, I'm going I dot A or A dot I. What is A dot I here? It will be AX, because A vector is what? A vector is AXI plus AYJ plus AZK, right? So if you are getting dot product of A dot I, since it is commutative, I am writing like this. Okay, I dot A is A dot I, both are same. Okay, it will be AX only, the component only along I direction. So this A dot I is a projection of A vector along I cap. Okay, so this is the idea, this is the concept of projection operator. Okay, dot product and projection operator, this is the idea. So if you are understanding the idea of a projection operator, then it is easy. Okay, it is only the component of I direction only. So because I dot j is 0, I dot k is 0, both are 90 degrees, and cos 90 is 0, then both are out of the matter. So it will be A into, sorry, A minus AX, right? A minus AX, right? Okay, so this is the idea here, A minus AX. Now what is J cross A cross J? Please do it. J cross A cross J is what? Using back minus tab rule, A B C. What is J cross A cross J? It will be yeah, A into J dot J minus AY. I hope it is right. That is A vector minus AY, right? And similarly, what is K cross A cross K? It will be You can write it like this. What will be the answer? Don't try to do that calculation. It is easy.
M
Yeah, a minus a
A Y.
az. A minus az. Okay, this k. So k component. What is the component along k direction? It is az. Okay. So here what happens if you add these three, it will be getting 3a vector minus ax. Yeah. Ax
I cap.
cap plus ay j cap plus az k cap, right? So this is 3a vector minus a vector, that is 2a vector, right? So if you know this idea, you can do it right away, no problem. Okay, so that is the problem, that is the importance of vector triple product. So I hope you have understood this concept. Okay, right. So let me do this other problem. So there is okay, so what is the other problem? One second. Find the angles that A may make with B and C. Okay, find the angles that A makes with B and C if A cross B cross C is root 3 by 2C. Yeah, this is a little bit having a little bit problem here. So let's do it. Okay. So we have given. So I hope you have got the questions. Okay. So otherwise, let me write this question. So this question is find the angles that A makes with B and C. A makes with B and C. If we have given, if A cross B cross C is equal to root 3 by 2 into C vector. Okay, so how will you do it? So just first of all, you have given this thing. Okay, so if you are expanding this, it will be B into A dot C, right, minus C into A dot B, right, and that is equal to, we have we have this thing, it is B. Okay, so let's assume that this is B vector and this is the coefficient. Since it is a scalar quantity, this will be a scalar quantity. Okay, so this is the coefficient and this is the vector. Just let's assume that. Okay, here also this is the coefficient, this is the vector. Here if you compare this, there will not be a component of B vector here, right? So there is only coefficient of C vector. Okay, just like this, 0 into B vector plus root 3 by 2 into C vector. So there is no problem. Okay, so I am writing 0 into B vector. It is not no need to mention this. Okay, just to mention that the coefficient of B here, it is 0. Okay, so there is no problem in adding a 0 to this thing. Okay, so let me write it like this in order to understand. Okay, now from this, what you will understand, what is the idea from this, if you are comparing LHS side and RHS side. So if you are comparing LHS and RHS, what is the idea you get? So you'll get the coefficient of, right? So what is the C vector? Yeah, we'll get the coefficient of as A dot B, or we get the idea that A dot C equal to 0. Yes, if you're comparing this, you'll get A dot C as 0. Then what will be A dot B? A dot B is what? A dot B is equal to minus root 3 by 2, right? You got the idea? A dot B is minus root 3 by 2. And here, from here itself, you can understand the angle between A dot C equal to 0 means what? What is the angle between A and C? Sorry, A dot C equal to 0. What is the angle between A and C? It will be, so what is A dot C? If you expand, what is A dot C? It is,
90 degree.
yeah, it is 90 degree. Yes. So if at all an angle between two vectors is 0, it means that the angle if at all A dot C is equal to 0, two vectors dot product is 0, the angle between that two vectors is what? It is 90 degree. Okay, so here you will get the theta 1 is equal to, let's say this angle theta 1, it is equal to 90 degree. Okay, from here what is the angle? It will be minus, yeah, so modulus of A into modulus of B into cos theta 2. Okay, so this cos theta 2 is what? This cos theta 2 is, if you are getting cos theta 2, it is equal to minus root 3 by 2, right? So what is theta 2? It will be cos inverse minus root 3 by 2. What is cos inverse minus root 3 by 2? What is cos inverse minus root 3 by 2? It is 150 degree. So it is 150 degree. Cos inverse minus root 3 by 2 is 150 degree. You know how to calculate the angles and all? It is root 3 by 2. What is that? Cos inverse root 3 by 2. What is root 3 by 2? Is 30, right? 30 degree. It is root 3 by 2. It is 30 degree. If it is minus root 3 by 2, it will be going to other quadrant. The angle will be obtuse. Second quadrant it will come. Yeah. So when I'm discussing trigonometric relations and all, I'll mention that because that is very important to all of your calculations. You need to understand, you need to study trigonometric relations and all. Mostly, you need to at least practice the sin A plus B, sin A minus B, cos A plus B, cos A minus B. This kind of small idea you need to understand because that is very, very important. Okay. So whatever trigonometric relations you know, you can derive it from the sin A plus B, cos A plus B format. Okay. Whatever it is. So this is a very important relation in trigonometry. Just understand that. Okay. Right. So I'll explain it in the when the time comes. So right. So let me move on. So the next one will be. So we have discussed the vector algebra and vector notations and all. So another important thing is that the parallelogram law of vector addition. Okay. So if you're finding the resultant of two vectors, resultant of two vectors, let's say A and B, whatever direction, whatever arbitrary vector that is, if you have A vector over here, B vector over here, this is A vector, this is B vector. Okay, so what is the resultant? It will be, you can say like this, it is a parallelogram. Let's draw a parallelogram, then this resultant will be the diagonal. Okay, this one is the resultant of that vector. Okay, so how will you write that? So what is A? Yeah, what will be? It will be root of, the resultant will be root of A square plus B square plus 2AB cos theta. So this is the resultant of that two vectors. Okay, so if you want to find the resultant using parallelogram law, this is the idea. Okay, so just thought you will understand that this is a basic idea, resultant of two vectors. So now we'll move on. Now we'll move to the vector differentiation. Okay, so vector differentiation. So it's a very important idea because so many questions are there in vector differentiation. vector differentiation. So in vector differentiation, we'll discuss the differential operators of vector notation or vector calculus. Okay, so vector differentiation will discuss the mainly will discuss the operator called del operator. Del, you might have studied of this thing. So del operator. This is an operator. What is the definition of del operator? Del is the differential operator in 3 dimensions. Okay, differential operator in 3 dimensions, and also it is a vector. Okay, so it is I cap into dou by dou x, partial differentiation, plus j cap into dou by dou y, plus k cap into dou by dou z. So this is the vector notation of a differential operator, vector differential operator, or del operator. Okay, it's called a vector differential operator, vector differential operator, differential operator, or del operator. Okay, so there are so many things about vector differential operator. We'll do one by one. There is gradient, there is divergent, and there is curl. Okay, so we have different ideas that we have. Let me write it one by one. So this is a very important thing. Okay, understand that. So we have first one, we have del dot a. Okay, so let's define first. Let's define a as, let's define, let a vector be a vector function. So we have discussed vector notation. Okay, vectors just like axi plus ayj plus azk, but now we are focusing on vector functions. So what is the difference between a normal vector and a vector function? What is the difference? The normal vector will be some coefficient into the direction. Okay, so if you want to denote a vector in a particular location, whether it is a 3-dimensional space, it will point out as it will point a space or a particular point in space, and up to which that vector is located. So for example, if you have in 3-dimensional space, if you have a point like this, let's say it is 1, 2, 3, this is the point. Okay, so a vector will be that originates from this origin to, and it points in the direction of 1, 2, 3. So this vector can be denoted as I plus 2j plus 3k. That's it. So what it means that it will be having 1 unit length from x-axis, 2 unit length from y-axis, and 3 unit length from z-axis. You will reach the point here. This is the meaning. This is the actual very brief, very basic idea of what actually this vector points. Okay, so a point in space, a vector is used to denote, or we used to point to a particular point in space. Okay, so this is the idea. So it will be 1 unit from x-axis. If you are moving 1 unit from x-axis, 2 units from y-axis, and 3 units from z-axis, you will get a cube. Okay, and that point, final point, the notation point is will be 1, 2, 3. Okay, right. So this is the idea of a vector notation. And for a vector function, rather than this, for a vector function, the coefficient will be variables. Say for example, if you have a function like this, if you have a vector like this, a is equal to, say, if you have 2x I cap plus 3y j cap plus 4z k cap, right? So this is actually a vector function because this x, y, z are the variables. Okay, depending upon x, y, z, we'll get different values of a. Say if it is x, y, z are 1, 1, 1, then you'll get I 2xi plus 3yj plus 4zk. If it is 1, 1, 1. If it is 0, then a vector is equal to 0. Okay, so depending upon the value of x, y, z, we'll get different values of the function. So this is the difference between an actual vector to a vector function. Okay, so now we have defined a vector function. Let a be a vector function. Now onwards, from now onwards, if you are defining a, please memorize or please remember that it will be a vector function. And let phi, let's say it is phi, be a scalar function. A scalar function. What is a scalar function? Scalar function is nothing but if you have a particular value, just a scalar. If your scalar quantity, here it is 2. 2 is a scalar quantity. Okay, so here it also this 3y would be a scalar quantity. Okay, there is no vector notation here. The 3y, the coefficient 3y will be a scalar quantity. Vector so scalar function can be anything. For example, xyz. Xyz is a scalar function. 2xy is a scalar function. X square z is a scalar function. These are all scalar functions, examples of scalar functions. Okay, so I have defined a as a vector function and phi as a scalar function. Now let's do the problems. Let's do the notations once again. So we have different notations. Let's say it is del. First one is del dot a. Del is, remember, it is a vector operator. Okay, so I am not putting this vector symbol here because it is an operator, vector differential operator, but you don't confuse, this is also a vector. Okay, del dot a, then only we can do del dot a, otherwise we cannot do. Okay, two vector only we can do dot product, right? Now we define one more thing, it is del phi, gradient, and we define del cross a, and next one is del cross del, or del dot del, sorry, del dot del, right? So we'll define each of this. Del dot a means divergence of a, divergence of vector a. Okay, next, del phi is what? It is gradient of phi, gradient of a scalar function, a scalar function phi, right? Now what is del cross a? It is called a curl of vector function. We'll discuss this in detail, actually the physical significance of this and all in electrodynamics. And you study Maxwell's equation and all, you'll get the idea of this, what it means actually. So since I'm discussing mathematical methods, so I'll just mention this only. So curl of vector function, vector function, sorry, vector function. A. Now del dot del is the Laplacian operator. Laplacian operator. Okay, so this is the 4 different important differential notations. Okay, using del operator, we have 4 different things, 4 different sets. Okay, one divergence, one gradient, curl, and Laplacian operator. So we'll discuss one by one, right? Now, yeah, so we'll discuss each of them, each of that. So there is a important things like solenoidal, rotational, and all those things. So we'll discuss one by one. So next, first one is divergence of a vector function. Okay, so let me write it like divergence of a vector function. right? Divergence of a vector function. So let A be any differential function, the differentiable function. So we'll define A. We have already defined A as a vector function, vector function, which is differentiable, vector differentiable function. It should be differentiable because we are doing differentiation. Okay, here we are doing differentiation because del operator contains differentials. Okay, right. So let A be any vector differentiable function. Okay, we can define A be a vector differentiable function, and the divergence will be, so let's say that if you have this thing, so let's define A as, say it is A x I cap plus A y j cap plus A z k cap, three-dimensional vector differential function. Here remember this Ax, Ay, Az won't be any number. It won't be any number. It will be having x dependence, y dependence, z dependence. Say Ax will be 2xy, Ay will be 2x square, 3x square, or something like that. Az will be xy square, something like that. Okay. So there won't be any number only, but there will be a functional dependence. So variable will be there, right? Then, yeah, it should be differentiable. Okay. So now we have what is del dot, what is del dot A, what is del dot A. We'll define del dot A. It's a divergence. Okay. Now what is del? Is dou by dou x into I cap plus dou by dou y into j cap plus dou by dou z into k cap dot yeah, dot ax I cap plus ay j cap plus az k cap, right? So del dot A will be what? It will be, yeah, you know how to do it. It will be I cap into dou by dou x of ax. Sorry, I cap dot I cap, right? Dou by dou x of ax into I cap dot I cap. I cap dot I cap is what? 1. There is no other thing exists. Okay, only I cap dot I cap, j cap dot j cap, k cap dot k cap will be existing because I dot j will be 0, I dot k will be 0. Similarly, j dot I and j dot k will be 0, k dot I and k dot j will be 0, right? Only I, j, j and k, k terms will be there. There is only 3 terms. So that will be dou by dou x of ax. Yeah, it will be dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. So the answer will be dou ax by dou x. The answer will be dou ax by dou x plus dou ay by dou y plus dou az by dou z. So this is the answer. This is del dot A. So this is the answer. Okay. So so let me do one problem here. What is the position? Let's discuss about an important thing in the electrodynamics. It is the position vector. Position vector. Actually, the notation is R. The position vector. Okay. So this position vector are actually different notations are there in Griffith's electrodynamics. There is you can see different notations. Something like this also there, this also there. Some different notations are there. So I'm writing this notation. So the position vector R is actually in electrodynamics. If you want to define a position of a particular point in space, you use this position vector. Okay. So the same idea that I have explained earlier, the same idea here, the same idea that I explained earlier. If you want to define a position in a 3-dimensional space, 3-dimensional Cartesian coordinate system, you use the position vector, right? So what is a position vector R? What is the notation of position vector R? Position vector R is just nothing but R is equal to xi plus yj plus zk. So this is the position vector of R. Whatever be the position, if you want to denote a number, particular number in space, there is x dependence, there is y dependence, there is z dependence. Whatever the distance, according to that, we will get a position. Okay. So if x is 1, y is 1, z is 1, then we will get I, j, k, I plus j plus k. That is 1, 1, 1. That is a position of 1, 1, 1. Okay. And if a point in space like 1, 2, 3, you need to denote, then x will be 1, y will be 2, z will be 3. That's it. Okay. In order to define a position of a particular point, we'll use the position vector. Okay. Now, what is the differentiation of position vector? dr, d vector r cap, that is equal to dx I cap plus dy j cap plus dz k cap. We'll discuss this more detail in electrodynamics, because this dr is very important. It's actually the differential position vector. Is actually denoting a very slight change in the position of a particular thing. See, if you have a coordinate over here, and if you want to denote a position like this, so this is a point, this is a vector, this is a position vector r, and if there is a slight movement like this in this position, if a point just moves, okay, in a Cartesian coordinate system, this slight change is dr. Okay. So to denote this slight change, it is dxi plus dy. Since if it is actually the change in space, right? So it is denoting a change in space, and a very small change in space. So if there is a point and there is a slight change to that point in space, obviously there will be slight change in each of the coordinates, right? So since it is x, y, z, if there is a slight change, this x will change, this y will change, this z will change, because it is in a space. Both three coefficient will change. So to denote that change, we are giving this thing, dxi plus dyj plus dzk. So this is actually denoting a slight change in space. Okay, right. Now, yes, what is a position vector of what is the magnitude of this r? What is the magnitude of this r vector? What is the magnitude? It will be root of x square plus y square plus z square, right? So this is the magnitude of position vector. So please remember all those things. Okay, you'll get more details in electrodynamics. Please remember all those things. Okay, these are a slight thing. Now, a question comes. What is the question here? What is del dot r? So there is an important question. Actually, directly it's been asked in many of the entrance exam questions. So it is del dot r. What is del dot r? Where r is the position vector. So what is del dot r? So if you're doing del dot r, what will be it? I think I have given it as a question. So del is what? I dou by dou x. So anybody can answer? J dou by dou y plus k dou by dou z. Anybody knows the answer? Dot. What is the position vector r? It will be xi plus yj plus zk. What is the answer? This. What is the answer?
3.
Yes. So what? How it will be 3? It will be dou by dou x of ax, or dou by dou x of x plus dou by dou y of y. So the answer will be dou by dou x of x plus dou by dou y of y plus dou by dou z of z. Okay. So what is dou x by dou x? 1. Dou y by dou y is 1. So 1 plus 1 plus 1 is equal to 3. So del dot r is nothing but 3. Actually, del dot r, how it becomes 3? Since r is the vector, position vector in 3-dimensional space, then it is 3. If it is in multi-dimensional space, it will depend upon what? What is the dimensions of that space? Okay. Since it is a three-dimensional space, I'm actually pushing the little bit advanced thing. If it is a four-dimensional space, then what happens? There will be another quantity also in four-dimensional space. So depending upon that, the del operator also will change. It will be a four-dimensional del operator. Okay, so if you extend it, you are just getting the idea of the space, what dimension that space is. Okay, since it is a dimension space, it will give the dimensions of that space. So the physical meaning is that del dot r will give the dimension of that space, will give the dimensions of that space, dimension of the space where the vector is situated. Okay, right. Since it is a Cartesian, three-dimensional Cartesian space, it will be 3. Okay, right. Okay, so that's the physical idea. Now, now one more question, then I think we'll wind up. Okay, what's the time? 9:43, right? So how much time do I have? Rashid is there? Okay, no problem. We'll do. We'll wind up with one more problem we discussed. Okay, right. Now, yeah, one more problem which I have given is this. We have given the vector function. I think it is f is equal to 3x square I cap plus 5xy square j cap plus xyz cube k cap. Right. So you need to find del dot f, divergence of this vector function f at 1, 1, 1 or at 1, 2, 3. What is? Anybody have the question papers in hand? Is it 1, 2, 3 or 1, 1, 1? Okay, let's do this thing. So,
Sir, it's 1, 2.
1, 2, 3, right? Okay, right.
Yes.
So we'll do this thing. So what is del dot f? First of all, we need to. So if it is given like this, find divergence of this function at the point 1, 2, 3 means that just find the divergence and put in the terms of x as 1, y as 2, and z as 3. That's it. Okay, if you want to find this particular point, at the particular point, the divergence at a particular point, you just do it, do the divergence, then find the point. So put the points. That's the case of x, y, z. Right. So what is del dot f here? I dou by dou x plus j dou by dou y plus k dou by dou z dot this function. Okay, so as I said earlier, there is only I component, the j component, k component will multiply. There is only 3 other components, so it will be directly we can write dou by dou x of 3x square plus dou by dou y of 5xy square plus dou by dou z of xyz cube. See, the importance of or the easiness of this dou by dou x, this partial derivative is nothing but you can easily do the differentiation. Okay, if it is so please if it is xy dependence here, there is only need to we only need to discuss about y component. Okay, x is actually constant here. So x is actually constant when y are taking. This is the importance of partial differentiation. Okay, so whatever function is there, with respect to what function you are doing this differentiation, partial differentiation, other functions will become constants. Now, what is dou by dou x of 3x square? It is 6x. Right. You know the differentiation, I think. It will be what? This will be what? 10xy, right? 10xy, right? So I'm directly doing, by knowing that you know that something about differentiation, d by dx of x raised to n is equal to n x raised to n minus 1. Okay, right. So this method I am applying, it is the 3xy z square. This xy is silent and z cube is 3z square, right? So if you want to find this thing at 1 2 3, just put x as 1, y as 2, z as 3. So it would be 6 plus 10 into 2, that is 20, I think. 20 plus 3 into 2, 6 into 9, 54. Right. This is 3 square, that is 9. Okay. 9 into 2, 18. 54. So 60 plus 2, 80, I think. The answer is 80. Everybody got this answer? Got this answer?
Yes, sir.
Right. Okay. So just if you need any guidance to understand this differentiation and basic differentiation, I mean very basic differentiation, and some of the trigonometric ideas about very basic ideas, just contact me. Okay. So I hope it is not a problem. Just feel free to contact me, because I don't think everybody knows the idea of differentiation as in a basic level. So I'll explain. So here, now one more important idea. If a vector is solenoidal, so if a vector function A is said to be solenoidal. Solenoidal is an idea, solenoidal. So that this means that, it's very important, it means that divergence of that vector, del dot A, will be 0. So this is the idea. This you will study more detail. Actually, this will be asked in the form in the electrodynamics session. Actually, so if a vector function is said to be solenoidal, that is, in electrodynamics we'll discuss force fields. Okay, force is a vector. So if you have vector fields like force field like this in the form of a vector function, if that force field becomes solenoidal, this means that divergence of that vector function will be 0. Okay, so this is the idea. Now, or it is also defined as divergence, div of A. Div of A is equal to 0. So divergence of A is equal to 0. Okay, so so we'll discuss actually these questions. We'll discuss questions in the, I think. Okay, so one more question I think we'll do, because this time. So one more questions we'll do in terms of a solenoidal thing. So right. So this type of questions will be asked in most of the entrance examinations. Okay. So the question is, find the value of lambda such that the given vector function is solenoidal. The given vector function is solenoidal, right? And you have, I think you can do it as a homework. You can do it. The function is given as lambda x square y plus yz into I cap plus x y square minus x z square into j cap plus we have 4x yz minus 2x square y square into k cap. So this is the vector. This is a big function. So this is given. So this means that yeah, you get an idea of divergence of a vector function. It is very easy since it is having a very big force vector function. It doesn't mean that it is difficult to solve. Okay, so just you need to do that. If it you get the idea of solenoidal. Okay, what is solenoidal? Then you can. It is very easy to do. Okay, so if it is del dot, the solenoidal idea is the entire idea comes in this del dot f is equal to 0. If you know this thing, it's very easy. Just rest of it is very basic calculations. Okay, so see, you get the idea. Here lambda, I'm putting lambda. There is only in I cap coefficient. This is also in there is only in I cap. Here only we will get lambda. Okay, here we won't get lambda. Here we won't get lambda. So this means that it is still again more easier. Okay, so just you need to do this only. This you need to do this only thing. Okay, so what is this? So how will you do this thing? Dou by dou x. So I into the same idea. I into dou by dou x of lambda x square y plus yz is equal to 0. Okay, that's it. So what is the answer? What will be the answer?
-3.
-3. Right. Correct. The answer will be -3. It will be 2 lambda xy. Okay. Plus one more thing is there. So yes, this thing will be what? This thing. Yeah, we need to do this thing also. Sorry. What is this thing? What is dou by dou y of this thing? Dou by dou y of this thing what? 2xy. This one is 0 because there's only x and z, right? Okay. Now plus here what happened? Here it is x and y. It is 0 because there is no z component. Here only we'll get z component. It will be 4xy is equal to 0. Right. So the differentiation, if you're finding it, it won't be difficult because since we are doing it as a partial differentiation, it won't be difficult, that much difficult. Okay. So only you need to look for the correct. What you need to do is you need to look for what actually with respect to what you are actually differentiating, whether it is in dou by dou x. You have to look for only x components. Okay, so x parts. Okay, see here, so that's why when you are differentiating with respect to x over here, the first term, this term will not be there. Here we are differentiating with the y only, so this term will not be there. and here only we are differentiating with respect to z, so this term won't be there. So that actually it is very simpler. So whatever be the idea, the answer will be very simple if you are doing partial differentiation. So here what happens, it will be lambda x square y, sorry, lambda 2 lambda xy plus 2xy plus 4xy, that is 6xy is equal to 0, right? So lambda is equal to, so if you are putting the value, yeah, putting the value for here, so what happens, it will be xy are getting outside, so xy equal to 0, so 2 lambda plus 6 into xy is equal to 0, right? So xy will not be 0, so then 2 lambda plus 6 is equal to 0, this is the idea. So 2 lambda is equal to minus 6, lambda is equal to minus 3. Answer is minus 3. I hope you have understood how to do this problem, right? Now, I think we will wind up the session here because so this is the idea of divergence. So we'll discuss gradient of a scalar function and curl of a vector function and irrotationality and all those things. Then we'll move on to the integration, vector integration part, so that we can wind up the session of vector calculus. So since it is very important, that actually more in HCU questions and all, entrance examinations and all, more about divergence and curl of a vector function is asked. I have seen the questions, so you'll get that questions in your practice test and as well as in the workout problem session in the next coming chapters or coming classes. So I have collected all those problems, so we'll discuss that one by one, right? So is there any doubt for what I have learned, what you have learned today, what I have discussed? So please ask if there is any doubt, right?
Sir,
Yes, tell me.
I had out in a question that you solved. Sir. Find the
Which one?
angles that A makes with B and C.
Yes.
Sir, in that after few steps, A dot B equals to minus root 3 by 2. Sir,
Yes, yes.
after that, it's just converting that into modulus of A modulus of B cos theta 2.
Yeah.
But what happened to that modulus A modulus B? Isn't it?
This modulus of yeah, this A dot B is actually yeah, that, and if as I'm not looking onto this means that, so if you are looking into modulus and modulus of B, the angle actually is see, when you're discussing about angles, so we are only looking into dot product results. Okay, so dot product results will be if you are taking modulus of n modulus of b as a whole, so please take that magnitude as maybe you can take the magnitude as 1, no problem with that, I think. So we are only discussing about angles here. So if it is, yeah, I know what you are saying, because that modulus of a modulus of b will be having some values, right? You are saying like that. So if you are comparing that, I think you only need to look for the angle. As I also having some doubt with that problem, because just right away they are taking like as in the angle session, right away they are taking as theta is equal to, because this A dot C is equal to 0, since the theta is equal to 90 degree, they are directly taking. So right away, so if they are taking like this, since A dot C is equal to 0, they are taking that theta is equal to 90 degree, then you can easily understand that it's A dot B also minus 3 by 2. You can take the theta directly as so theta as directly as cos inverse minus 3 root 3 by 2. Otherwise, we cannot take both. Okay. So if you're comparing that, yeah, directly you can take like this. I hope there is some so some more, actually I hope there is some more idea that which includes in the question, that this modulus of A and modulus of B and modulus of C, they should be written. Okay, then only that problem will get more clarification. Okay, so this modulus of A and modulus of B and modulus of C, since we don't know, it is actually a bit vague process that we are doing. If you know modulus of A, modulus of B, and modulus of C, it is very easy, because it is, if it is known, then only we can compare that. So I think that question needs some more clarification in terms of writing modulus of A and modulus of B. Otherwise, they should write this A, B, C are unit vectors or something like that. Okay. So I hope, yeah, I think it is right. What you're saying, it is right.
Yes, sir.
You need some clarification bit of modulus of A and modulus of B. Yes, that's right. I think the problem session on also they need to discuss that, since that modulus of A and modulus of B is equal to 1 or something like that. They should discuss, I think. No, just make sure that you understand what a cross product means. Vector product means, vector triple product means. Okay, just to understand that only, I have written this. Okay. Now, any doubts? So, right. Where should you see this?